Mm. Good morning, children. Have a nice day. So, which chapter I started previous? That is heat and measurement. Already quick recap for this lesson. What I explained before. That is one form of energy is transferred into another form of energy. Already we discussed. I gave you examples also. Rubbing of the palm. Mechanical energy is converted into heat energy. Already electric heaters, electric energy is converted into heat energy. Solar heater, solar energy is converted into heat energy. So electric iron, the electric energy is converted into heat energy. So already we discussed heat. What is a heat? Is a measurement, temperature. It is a temperature, measurement of temperature only. So now here we know that. So when you sit near the fire, what you feel? Your body becomes warm. Your body becomes warm. So higher temperature to the heat is transferring from higher temperature to lower temperature. The heat is transferring from higher temperature to lower temperature. In the same way, I gave example of cup of tea, or your mother gave you a glass of milk, hot milk, and she brought one spoon to shake it well. So when you keep the spoon, which is in cool, the spoon is cool, the temperature is very low. When you keep it, after some time, the heat wave from the hot milk transfer to spoon, transfer to metallic spoon. So here, what you are observing here, the temperature is flowing from higher object to higher temperature to lower temperature. Understood? So here, what is a temperature? Temperature is a hotness or coldness of a body. It's called its temperature. So already we discussed about the motion and time. How we measure the time by using different instruments are there. In the same way, for measurement of heat, we are using the instrument, that is what you call it, thermometer. It is called a thermometer. Thermometer is used. There are two types of thermometer. This what I mentioned here is a laboratory thermometer. This is a laboratory thermometer. The thermometer which is used in the labs for chemical reactions, we use melting point or boiling point, we use laboratory thermometer. In the same way, clinical thermometer or doctor's thermometer we use to measure our body temperature. So this clinical thermometer, mercury, or it is also called as a mercury thermometer. Nowadays we are getting even digital thermometers which works with the battery, isn't it? Which works with the battery. So here you are seeing this thermometer is using. Here it is filled with the mercury. Because some property will be there. That's why we use mercury only. It is a good conductor of heat. So mercury is used in the thermometer. This is called the laboratory thermometer. Here this is the glass tube is there, and what you are seeing here is a capillary tube which is filled. This is called the bulb of the thermometer. This is called glass tube. This is called capillary tube. And this glass tube is calibrated with the readings 0 to 100 degrees. The glass tube is calibrated with the reading that is 0 to 100 degrees. And what they will do, they remove the air and it is sealed. Remove the air and it is sealed. Air is not there. They remove the air and it is sealed. Okay, so here you are seeing this arrangement of the marks is called a scale of, what do you call it? Scale of temperature. This is called the scale of temperature which you are seeing in the laboratory thermometer. Here you are seeing the laboratory thermometer. So all the thermometers are based on the fact that matter expands on heating. All the thermometers are based on that matter expands on heating. What we are using here? Mercury. Mercury expands on heating. So it is a good conductor of heat. So we are using the mercury. So to understand the thermometer, we need to know how the matter expands. Here you are taking, what you are taking is a glass trough. Take a glass trough filled with the boiled water. What you are taking in this? Boiled water you are taking. What you have to understand here, matter expands on heating. Mercury is a liquid state. You will study about the periodic table. in higher classes, mercury is one of the metal which you find in the liquid state. Its expansion is uniform. So here you are taking the mercury. So here I am taking the boiled, how the matter expands on heating. That I want to show you with a simple experiment. Take the boiled water in the glass trough. Now take a round bottom flask. What you are taking? Round bottom flask. This round bottom flask is filled with the colored water. Red water, color. You add little color. Colored water you are taking in this. Colored water you are taking. Now here, take the one whole rubber stopper and fix it to the round bottom flask. Understood? Fix it to the round bottom flask. Small hole make it. One whole rubber. Now pass a capillary tube through this hole. Pass a capillary tube through this hole. Now your apparatus is ready. What happens here? What you are taking here? You are taking the boiled water and you are taking the colored water in the round water flask which is not boiled. You are not boiling this colored water. Only water you are taking and capillary tube you are keeping in this. Okay. What is this experiment? Matter expands on heating. So here from where the heat is getting to this cool water? From the boiled water. When you keep the round bottom flask in the boiled water, what happens? The colored water received the heat from the boiled water. The colored water received the heat from the boiled water. Now here what happens? This colored water, where it enters then, where is the place to enter the water? Where is the place? So after receiving the heat, the liquids expand. The volume of the liquid extends, increases. So the water will be enters into the capillary tube. This capillary tube is calibrated with the readings. The capillary tube is calibrated with the readings. So on heating, liquids expands. What you understand by this experiment is you connect it with the thermometer. On heating, the liquids expands. Now take out the round bottom flask from the trough. Keep it aside. What happens? After cooling, again the colored water will goes into this from the capillary tube. The water enters into the round bottom flask. On cooling, the liquids contracts. On heating, liquids expands. Understood? So here, this is the reason why apart from mercury, we are using mercury. Apart from mercury, we can use even alcohol also. In 6 maximum minimum thermometer experience you working and construction of maximum thermometer, what the bulbs we use in the bulb? We use alcohol. We use alcohol in the bulbs. So apart from, you can use mercury as well as alcohol in the bulbs. So here now, why we are using the mercury in the thermometer? What are the properties of the mercury? It is a good conductor of heat. First property of the mercury is it is a good conductor of heat. And its expansion is uniform. Throughout its expansion is uniform. When it receives the heat, its expansion is uniform. It does not stick to the walls of the tube. It does not stick to the walls of the tube. It is found in the liquid state and it is opaque and shining. It is opaque and shining. The light does not passes. It is opaque and shining because of these properties of mercury, and it is easily available in the market. It is easily available in the market. So it is easily available in pure state in the market. So mercury is used in the thermometer because of these properties. It is in liquid state, its expansion is uniform, it is opaque and shining, it does not stick to the walls of the thermometer. Because of these properties of mercury, the mercury is used in the thermometer. Now, alcohol. Why alcohol is used? It can record very low temperature also. Alcohol, we use it record low temperature and it can be colored brightly, hence easily visible. It colored brightly and easily available. So This alcohol also we can use 6 maximum minimum thermometer. We used alcohol in the bulb. Understood? So this is about this construction of the laboratory thermometer. I will explain you how to make your own thermometer and why the 0 degree we are using here. What is the 0 degree and why we are using 100 degree? Take this thermometer, laboratory thermometer, and take some ice cubes in the vessel. Take some ice cubes in the vessel and keep the thermometer, which the bulb of the thermometer should touches to the ice cubes. Note down the temperature. It will be, the melting point of ice will be 0 degrees centigrade, or freezing point of the ice is 0 degrees centigrade. How long you keep? It will shows you 0 degrees only. So, freezing point of ice is 0 degrees centigrade, and in the same way, take the vessel, heat the water by using the Bunsen burner, boil the water, keep the thermometer in this. When the water starts boiling, at that time note down the temperature. The temperature will be boiling point of water. The temperature will be 100 degrees centigrade. If you keep for longer time also, it will be constant. The temperature will not change. So, the boiling point of water is 100 degrees centigrade. That is BP. Boiling point of water is 100 degrees centigrade. Melting point of ice is 0 degrees centigrade. You can find it. And one more thing is you are not keeping the thermometer. You are keeping to the side of the vessel. No. Both the objects should be in touch. Then only. Now you want to take your body temperature and you are keeping it on the table and you are taking the temperature. Is it possible? Not at all. So, the bulb of the thermometer should be in touch with the object which you are going to measure. Understood? Both should be in contact. So, here, how much a long time you are keeping, it will shows you the same temperature. There is no change in the temperature. Constant temperature, it will show you. Thank you children. Have a nice day.